The first question says, evaluate square root of 4900. So we know 49 is 7 times 7, which is basically equal to 7 squared. And 100 is 10 times 10, which is 10 squared. So if we split 4900 into 49 times 100, and then further split the 49 into its prime factors, 7 square, and 100 into 10 square. Now square root of a square number is always equal to the number itself, which means square root of 7 square will be 7, and square root of 10 square will be 10. So we've gotten rid of the square root sign, and 7 times 10 is 70. Evaluate 5 cube, which means we'll do 5 times 5 times 5. We know 5 times 5 is 25. Now 25 times 5 is 5 5s are 25. 2 5s are 10 plus 2, 12. 125 is your answer. Whatever the power is of a number, you multiply the number that many times to itself. Let's say it was 5 to the power of 6. So then you would have multiplied 5 6 times to itself. Question 2 says work out -8 plus 7 times -5. So we're going to follow the rules of BIDMAS over here. Brackets first, then your indices, followed by division, multiplication, addition, and lastly, subtraction. So based on the rule, we will do this first. The parentheses with -5 is just added to separate the negative from the multiplication sign. So we don't have to really solve over there. It's going to be -8 plus 7 times -5, which is -35. So now we have -8 plus -35. So now we have -8 plus -35, which is going to give us -43. When we have two negative integers being added, the result is always going to be negative. And what you do is you end up adding the numbers. Question 3 says shade one more small triangle so that the shape has rotational symmetry of order 3. So let's start rotating the shape first and see what we get in the third order. So if we rotate it once, okay, so this is the first. And with this rotation, we'll have these two colored over here and these two colored over here. And this colored over here. So this is your first rotation. Now for this second rotation, For the second rotation, what's going to happen is going to have this over here, this over here, and this like this. So now for the third rotation, we're going to have this over here, this over here, and these over here. Which means to have the third rotational symmetry order, we need to shade this over here. Write down the name of the solid form from each net. The first one is going to be a cuboid. The second one is going to be a pyramid with a square base. Third one is going to be a triangular prism. Triangular prism. Question 5 says in the diagram ABCD and EFGH are parallel lines. The lines CF and BG intersect at X. CFG is given as 53. BGF is 46 and BXC is 81. We have to find CXG first. So this is the angle that we're trying to find. If you remember parallel lines, if we have a transversal passing through them, firstly, these two angles are alternate angles. Let's call this A and B, and alternate angles equal to each other in parallel lines. Then if we talk about the other type of angle in parallel lines, this and this. So let's call this C. These are corresponding angles. And in parallel lines, corresponding angles are equal. Apart from this, we have vertically opposite angles. So vertically opposite angles are also equal, which in this case is going to be A equal to C, which is these two. And lastly, what we have is co-interior angles. Co-interior angles add up to 180, which means A plus D is going to equal to 180 degrees. These are the main properties of angles in parallel lines. So if you look at our shape over here, if this angle is 53, we know this angle would also be 53 because alternate angles. If this is 46, this would be 46 because once again, alternate angles. For angle CXG, these two angles lie on a straight line. So when angles lie on a straight line, sum of their angles is going to equal to 180, which means if we do 180 equals to CXB plus CXG. So that is 81 plus CXG, 180 minus 81. And that is going to give us 99 degrees. That is your angle CXG. And the reason is that angles on a straight line add up to 180. This is find BCX. So BCX is this angle. So like we said previously, that alternate angles are equal. This angle and this angle over here, these two are alternate. So BCX is also going to be 53 degrees. Then ABX. ABX is this part. Once again, we said that this is 46 because alternate angles are equal. This angle and this angle lie on a straight line. So their sum of angles is going to be equal to 180. So ABX plus CBX, 180 equals to ABX plus 46. 180 minus 46 equals to ABX, and that is going to give us 134 degrees. That is your answer. Work out 69 divided by 0.3. So let's rewrite 0.3 as a fraction first. In order to do that, we'll move the decimal one place to the right, and that gives us 3 over 10. Then we'll move the decimal one place to the right. We add a 0 with the 1 in the denominator. Basically, every number has a denominator of 1. So if we're moving the decimal one place to the right, it becomes 3 over 10. We attach a 0 in the denominator and move the decimal from the numerator. So now take the reciprocal of 3 over 10, which is going to be 10 over 3, and switch the division into multiplication. So now we have 69 times 10 over 3. 69 comes in the 3 times table. 3 ones are 3. And 3 times 23 is 69. So we do 23 times 10, and that is 230. Work out one whole number 4 over 7 divided by 3 over 5. First, we'll convert the mixed number. This is the mixed number into an improper fraction. So to do that, we multiply the denominator with the whole number. So 7 times 1, which is 7. And then we add the result to the numerator. So 7 plus 4, and that is 11. So this is your new numerator. And the denominator remains the same. So the improper fraction is going to be 11 over 7. So we're going to write 11 over 7 instead of one whole number 4 over 7 divided by 3 over 5. Just like we did in the previous question, I'm going to take the reciprocal of 3 over 5, divide the fractions, and change the division into multiplication. So 11 over 7 times 5 over 3. 11 times 5 over 7 times 3, which is 55 over 21. They're asking us to give the answer as a mixed number in its simplest form. So to convert an improper fraction into a mixed number, we divide them. So 55 divided by 21. 21 times 2 is 42, which is a number that is directly less than 55 that comes in the 21 times table. 5 minus 2 is 3, 5 minus 4 is 1. So your answer is 2 whole number, 13 over 21. By writing each number correct to one significant figure, estimate the value of this. 8,230 correct to one significant figure is going to be 8,000. Leading zeros don't count as a significant figure. 0.64 is going to be 0.6. Zeros before the decimal don't count as a significant figure. And 18.7 is going to be 20. So all these three numbers are correct to one significant figure. So it's going to be 8,000 times 0.6 over 20. We can cancel out the zeros. 2 ones are 2, 4 hundreds are 800. So now we have 400 times 0.6. We can rewrite 0.6 as 6 over 10 like we did previously. Cancel out the zeros, and 40 times 6 is 240. That is your answer. Write 0.06 kilometers in meters. 1 kilometer is equal to 1,000 meters. So 0.06 kilometers will be equal to 0.06 times 1,000. When you're multiplying by 1,000, a 10 or 100, you move the decimal towards the right side based on how many zeros are there in the number. So since there are 3 zeros in 1,000, so move the decimal 1, 2, 3. That's going to be 60 meters. Convert 7 meters square to centimeter square. We know 1 meter is equal to 100 centimeter. So for 1 meter square, we multiply 100 centimeter with 100 centimeter, which is 10,000 centimeter square. So for 7 meters square, we multiply 7 with 10,000, which is going to give us 70,000 centimeter square. Write 216 as a product of its prime factors. So let's break down 216 into its factors. We can start with any factors. If we divide 216 by 2, we get 2 ones are 2, 0, remainder, bring the 1 down. 1 doesn't come in the 2 times table, so we add a 0 over here. Subtract 0 from 1, remainder 1, then 6 down, and we know 2 8s are 16. So 108 times 2 gives us 216. 2 is a prime number, so we can't break it down. Now let's break down 108. For 108, it's 54 times 2. 54 is 6 times 9. 6 is 3 times 2, and 9 is 3 times 3. So as you can see, all of these numbers are in the prime factor form. We cannot break 2 further down. We cannot break 3 further down. So these are the prime factors. So now to write them as a product, 2 times 2 times 2, we have 3 2s, and we have 3 3s. So that's going to be 2 cube times 3 cube. That is your answer as a product of prime factors for 216. Then says the positive integers are each greater than 25. Their lowest common multiple is 216, and their highest common factor is 18. Find the two integers. So we already know that 216 is 2 cube times 3 cube. Okay. And they're saying that for these two given integers, they're greater than 25. So let's say the first integer is x, and the second integer is y. So x is greater than 25, and y is also greater than 25. Next is saying that the lowest common multiple is 216 for these two integers. Next is saying is that the highest common factor is 18. So for 18, so if you look at 216, that's 2 times 2 times 2 times 3 times 3 times 3. We know 18 is 6 times 3, 9 times 2, and 18 times 1. If we do 2 times 3 with 3 times 3. Why? Because we know 2 times 3 is 6, and 6 times 3 is going to be 18. So since 18 is the highest common factor of this number, so we can multiply any other number with 18 to see what the integer is. Since we know that the highest common factor is 18, so we can pick the different combinations of 18 and multiply a different factor to it and see what kind of a integer we can get. So if we do 6 times 3, which is 18, and we multiply 3 with that, for example, we do 6 times 9. 6 times 9 is going to equal to 54. So we can assume this to be one of the factors. Let's say we do 6 times 12. So that is going to be 72. So for 6 times 3, the combinations we have is 6 times 9 and 6 times 12, which give us 54 and 72, which can be one of these integers. We can also say, use the 9 times 2 combination. So if we do 9 times 2 times 4. So 9 times 2 times 4 is going to give us 72 again. We can say 9 times just 4. That's going to give us 36. 9 times 6, which is once again 54. Another combination we can make is 9 times 12, which is going to be 108. So as you can see, what we did was we took the factors of 18, which was 6 times 3, 9 times 2, and 18 times 1. We chose these two sets of factors. And we started multiplying other factors from the prime factorization of 216 to find different combinations of the integers. So you can use this as an integer, you can use this, this, this. All these 4 possible options are correct. The diagram shows triangle A and triangle B. So these are the triangles. Describe fully the single transmission that maps triangle A onto triangle B. So let's pick 2 corresponding points on the shape A and B. So this is 3, -2, and this is 7, -4. So let's see how 3, -2 becomes 7, -4. So to turn 3 into 7, we add a 4. And to turn -2 into -4, we subtract a 2. Which means there is this translation by the vector 4, -2. The reason why it's a translation, because if it was a rotation, the direction of the shape would be different. And if it was an enlargement, the size of the shape would be different. So since there's no difference in the size or the direction of the shape, it means it's a translation. And if it was a reflection, it would be on the opposite side of the grid. Even that's not happening. So It's a translation by the vector 4, -2. Triangle A is mapped onto triangle C by rotation of 90 degrees anti-clockwise, center 0, 0. Draw triangle C. So first, let's mark the center. This is a center, and it's a 90 degrees anti-clockwise rotation of triangle A. So that means it's going to be in this direction. So our shape is going to be in this form now because we're rotating it anti-clockwise. So for it to be anti-clockwise like this, our first point this is a 90-degree angle over here. If we're rotating at the center 0, 0, which means this point over here will be over here. And then the corresponding points 2 units towards the right, this, and 1 unit down. This is how you make your 90 degrees anti-clockwise rotation for triangle A from center 0, 0. So this is going to be C. Draw a 90-degree angle from the center of your rotation towards the chosen point and then plot the points accordingly. This was 3 units horizontally and 2 units vertically. Now it's 2 units horizontally and 3 vertically. The distance has swapped now. 2 over here. So now it's 2 over here. 3 over here. So now it's 3 over here. Make sure to swap the distance like this, and the point needs to be at 90 degree from the original point to the new point. Then triangle A is mapped onto triangle D by an enlargement scale factor of 3, center 5, -5. -5 center is over here. So enlargement by scale factor 3. So if we draw a line from one of the points towards the center, there's a distance of 2 blocks. So that means for the enlarged shape, the distance would be 6 blocks now because the scale factor is 3. So you multiply the original distance by the scale factor. This is your distance of 1, 2, 3, 4, 5, 6 blocks. So your point will come over here. And now this distance is 2. So that means this distance over here will be 2 times 3, which is 6 again. So 1, 2, 3, 4, 5, 6. This is your next point. And this distance is 1. So that's going to be 1, 2, 3. You just multiply your distances of the original shape by the scale factor, which is 3. And this is your enlarged shape D. You can also check if your shape is correct by drawing lines connecting the original point to the new point and making sure that it passes through the center. That's how you check your placement of the center as well. So as you can see, they all pass through the center. The new point touches the old point. So this is your enlarged shape. Remember to multiply the scale factor with the original length to get the new length. The scale diagram shows a garden with 2 trees P and Q. The scale is 1 centimeter represents 6 meters. The garden has a path that is equidistant from P and Q. Using the straight edge and compasses only, construct the path. So if it's equidistant from P and Q, you'll draw a perpendicular bisector of P and Q For that, you'll open your compass. You'll first measure your distance of PQ. Then you'll open your compass more than half of the distance of PQ and put the pointed part at P and draw an arc above and below the line. Then you'll repeat the same steps from point Q with the same distance and draw an arc above and below the line. Once you've done that, you will connect the two arcs. And this line over here, this represents your perpendicular bisector. And this shows the locus of all the points that are equidistant from P and Q. Then it says that Yuna wants to plant a third tree in the garden that is nearer to Q than to P and more than 18 meters from Q. Shade the region where she can plant the tree. So it's nearer to Q than to P and it's more than 18 meters from Q. So we know that 1 centimeter to 6 meters is our scale. So if we divide 18 by 6, that gives us 3 centimeters. So the distance that the point is from Q is 3 centimeters now, which we can use to draw on the scale. You will open your compass to 3 centimeters, put the pointed part at Q and draw a circle with the radius of 3 centimeters. And it already says that it's 18 meters, more than 18 meters from Q. So which means it's going to be outside the circle, but it's nearer to Q. So you had your perpendicular bisector somewhere over here. This is going to be your place where she can plant the trees. This distance is 3. So 3 centimeters away from Q all around, between the perpendicular bisector that we drew, and it's nearer to Q than to P. So this is it. Question 12 says the diagram shows a rectangle ABCD. E is the point on the diagonal AC such that DEC is 90 degrees. Prove that the triangle ADC is similar to the triangle DEC. So we have triangle ADC and triangle DEC. So let's draw a column over here. So firstly, we know that angle DEC is 90. And since it's a rectangle, so angle ADC is also 90. So they share the same angle. DC is common for both. Then next what we have is angle C is also common. So common. The next common thing we have is angle C. So angle ACD is the same as angle DCE. We already know that this is 90, this is another angle that's common. So that means the third angle, which is angle DAC, and third angle for this one, which is EDC, that is going to be equal to each other because sum of angles of a triangle equal to 180. So if we do 180 minus 90 minus angle C, that's going to give us angle D. And if angle C is common for both of them, so the measurement of this angle and this angle is also going to be equal. So that's how we show that these two triangles are similar triangles, because their angles are exactly the same. The mean of 5 numbers is 17. The numbers are listed in order of size, starting with the smallest. The 3 smallest numbers are equal. The middle 3 numbers add up to 35. And the largest number is 4 times the smallest number. So let's assume that your smallest number is equal to x, which means our largest number is going to equal to 4x because it's 4 times the smallest number. We have 5 numbers in total. So let's write down these numbers in ascending order. So we have 3 smallest integers are equal. So x plus x plus x. And we don't know what the middle one is. So let's call that y. And the fifth one, the largest is 4x. So these are the integers in ascending order. They're saying that the middle 3 numbers add up to 35. So middle 3 numbers are these 3 numbers. X plus y add up to 35 according to the question. So the equation we have is 2x plus y equals to 35. And we can say y is equal to 35 minus 2x. This is our first equation. Next equation is going to be based on the mean. Mean of the 5 numbers is 17. So that means x plus x plus x plus y plus 4x divided by 5 equals to 17. This is your mean. So we can simplify the numerator by adding all the x values. So x plus x plus x plus 4x is 7x plus y over 5. Cross multiply to get rid of the fraction. So 7x plus y equals to 17 times 5, which is going to be 85. We know y is 35 minus 2x. So let's replace y with that. 7x plus 35 minus 2x equals to 85. As you can see, now we have the entire thing in terms of just x. There is no other unknown. So let's further solve this over here. So that's going to be 7x minus 2x is 5x plus 35 equals to 85. 5x is 85 minus 35, which is going to be 50. So x is 10 over here. So the 5 numbers are going to be 10, 10, 10. For the y value, we put x equals to 5 in the first equation. So that's going to be 35 minus 2 times 10. 35 minus 20 is 15. So 15 is your y value. And then 4 times 10, which is your largest integer. So 10, 10, 10, 15, 40. These are your 5 numbers in order of size. Question 14 says diagram shows the speed time graph for the start of a cyclist journey. Find the acceleration during the first 20 seconds. So this is our first 20 seconds. In a speed time graph, your acceleration is basically slope of the graph, which means we need to find the slope of the graph from 0 to 20 seconds. This is going to be 1 point, this is going to be another point. This point has the coordinates of 20, 15, and this point, which is the origin, has the coordinates of 0, 0. So for acceleration, we do 15 minus 0 over 20 minus 0, which is going to be 15 over 20, and that is equal to 304 meter per second square, which is 15 over 20, and that is equal to 304 meter per second square. In case you're confused about the formula that we use the slope formula, which is y2 minus y1 over x2 minus x1. We have two sets of points, x2 and y2, and x1 and y1. So these were the coordinates that we used to replace these points. And then we plugged in the values in the slope formula and found the acceleration. Describe the motion of the cyclist between t is equals to 20 and t equals to 30. This is the motion of the cyclist during this point. And as you can see, it's maintaining a constant speed of 15, which means during this time, the cyclist has a constant speed of 15 meters per second. Then it says find the total distance traveled in the 50 seconds. So now if you look at the graph, to find a distance in the speed time graph, we look at the area under the graph. So area under the graph is the distance in a speed time graph. So in this case, what we'll do is we'll split the shape into two parts. This is going to be my first part. And this is going to be my second part. So we have these two shapes over here in this graph. We need to find the area of these two shapes to calculate the total distance for the journey. So let's call this A and let's call this B. So for area of A, as you can see, shape A is a trapezium. So area for trapezium is 1/2 times height times sum of parallel sides. So this is one parallel side, this is another parallel side, and this is your height. So that's going to be 1/2. This is for A. 1/2 times 15, which is the height. And for the parallel sides, it's 10 and it's 30. So 10 plus 30. So that's going to be 15/2 times 40. And that is going to give us 300 meters. Then after that, we're going to find the area of shape B. So for shape B, it's a trapezium once again. So area is going to be the same, 1/2 times height times sum of parallel sides. Over here, your height is this, and these are your parallel sides. So for shape B, the height is 20, 50 minus 30, and parallel sides are 5 plus 15. So that's 10 times 20, and that is going to be 200 meters. So total distance is the sum of these two values, which is going to be 300 plus 200, and that's 500 meters. That is the total distance traveled. During 1 year, the value of a bicycle decreased from $200 to $160. Calculate the percentage decrease in the value of the bicycle. So for percentage decrease or increase, your formula is new value minus old value divided by the old value times 100. So your new value is 160, old value is 200. So 160 minus 200 over 200 times 100, which is going to be negative 40 over 200 times 100. Cancel the zeros out. Negative 40 divided by 2 is negative 20. So the negative sign shows that it's a decrease. So 20%. Solve the inequality 23 plus 2n greater than 5 minus 6n. We will first begin with collecting the like terms on each side. So I'll take 6n over here and take 23 over here. So it's going to be 2n plus 6n greater than 5 plus 23. The reason why 6n is positive now is because you moved it from one side to the other side. And when you move things from one side to the other side, the operation they're performing changes. If it's being subtracted, then it gets added to the other side. If it's being divided, it gets multiplied to the other side. So that's why 6n is being added to 2n now, and 23 is being subtracted from 5 now. So that's going to be 8n greater than negative 18. Divide both sides by 8. So that's going to be n greater than negative 18 over 8, which can be simplified to negative 9 over 4. Factorize the following. So in this, we'll do factor by grouping. We'll divide the first two terms in one group, and the last two terms will be another group. So that's going to be, so if you look at the first two terms, we can see that we have only y common between them. So we'll write y brackets 3x minus q. Whatever is common, you take that term outside the bracket, and whatever is left behind stays inside the bracket. Then in the second group, we can see that we have 2p common. That's going to be 3x minus q. Now, as you can see, y and 2p have 3x minus q common. So we take 3x minus q common, and we're left with y plus 2p in the second bracket. So that's your answer. Question 18 says the diagram shows a shaded region ABC. The equation of the line AC is y equals to negative 1 over 2x plus 5. Write down the three inequalities that define the region. This is the first line, which is y equals to 2. So if we look at it as an inequality, we can see that we're looking at the values of y which are greater than 2. So that means y is greater than equal to 2, first inequality. For the next one, you have this line AB. So this is x equals to negative 4. So if we look at the line as an inequality, we can see that the shaded region includes values of x which are greater than negative 4, which means x is going to be greater than negative 4. And for the last line, AC, the equation we have is y equals to negative 1 over 2x plus 5. So for this line, if you look at the shaded region, we're looking at the values of y which are decreasing now, which means it's going to be y less than equal to negative 1 over 2x plus 5. So these are your three inequalities. Question 19 shows us a circle, and it says that A, B, and C lie on a circle with center O. The line PBQ, which is this line, is a tangent to the circle at B. OCQ is a straight line, this line. And angle BQO is given as 36. Angle BAC is given as x. Find the value of x. So first thing first, we need to remember that tangent makes a 90-degree angle with the radius. So this is 90. If this is 90, if this is 36, we can find this angle because sum of angles of a triangle equal 180. So we'll do 180 equals to 36 plus 90 plus angle BOQ. So 180 minus 90 minus 36. And that is going to give us 54. So this is 54. Now, in circle theorems, one of the properties is that angle at the center is twice the angle at the circumference. So this is the angle at the circumference, and this is the angle at the center, which means x is going to be half of 54. Because if the angle at the center is twice of the angle at the circumference, then the angle at the circumference is going to be half of the angle at the center. So that's going to be 27 degrees, which is your value of x. Find the inverse of this matrix. So the matrix is 3, 1, negative 2, 2. So let's start with finding the determinant of this. So we cross multiply the numbers and subtract the results. So 3 times 2 minus negative 2 times 1, which is going to be 6 plus 2, and that's 8. That's your determinant. Now we find the adjoint. That's going to be swapping the first and the last value and changing the signs of the second and the third value. So it's going to be positive 2 now and negative 1. So your inverse is going to be 1 over the determinant times the adjoint of the matrix. That's going to be 1 over 8 times 2, negative 1, 2, 3. You can multiply the fraction with the numbers inside the matrix, or you can keep it as it is. Either way, it's going to be correct. Question 21 says the cumulative frequency diagram shows the masses m grams of 120 eggs. Use the diagram to estimate the median. So since there are 120 eggs in total, so for the median, we will do 120 divided by 2, and that's 60. So we need the 60th value to find the median. So we go to a y-axis and draw a line from 60 towards the cumulative frequency curve. And what we get is 58. That is our median. In the next part, it says find the interquartile range. So for the interquartile range, we need the upper quartile and the lower quartile. For the lower quartile, we divide the total frequency by 4. So that's going to give us 30. So we need to find the 30th value. And for the upper quartile, we multiply total frequency by 3/4, which will give us the 90th value. So let's draw a line from 30 and 90. From 30, for the 90th value, that is going to be 62. So for the interquartile, we'll subtract the lower quartile from the upper quartile, and that's going to be 62 minus 51, and that's going to give us 11. This is our interquartile range. Then it says eggs are described as large if their mass is 63 grams or more. How many of these eggs are large? So for 63 grams or more, we draw a line from 63 towards the graph. And we get the corresponding value of 96 over here. So we do 120 minus 96, which is going to give us 24. So these are the eggs that exactly weigh more than 63 grams. Solve 27 to the power of k equals to 9. So we know that 27 is basically 3 times 9, and 9 is 3 times 3 times 3, which can be rewritten as 3 to the power of 3. All these equal to 27. And we know 9 is 3 times 3, which is equal to 3 square. So let's replace 27 with 3 cube whole power k and 9 with 3 square. Now, as you can see, we have the same bases over here. And when you solve the powers, when there's a power inside the bracket and outside the bracket, we multiply the powers. So that's going to be 3 to the power of 3k equals to 3 square. Now, next rule that we can use over here is that when the bases are equal, we can put the powers equal to each other, which means k is going to be 2 over 3. So we applied two rules of indices over here. First was the rule when there's a power inside the bracket and outside the bracket, we multiply them. And the second rule was when the bases are same, we can put the powers equal to each other. And that gives us the value of k. Then it says simplify this. So we know that when we have a negative power, in order to make it positive, we flip the fraction, which means we're going to rewrite this as x to the power of 8 over 16. Now whole power will be positive 1 over 4. Now let's distribute the power. X to the power of 8 whole power 1 over 4 over 16 to the power of 1 over 4. Same rule, whenever there's a power outside the bracket and inside the bracket, we multiply them. It's going to be 8 times 1 over 4. And the root of 16 is basically what? So we know 16 is 4 times 4. And 4 is 2 times 2. So as you can see, 16 is equal to 2 to the power of 4. So if we replace 16 with 2 to the power of 4 and take the fourth root, that's going to give us 2, because fourth root of a number raised to the power 4 is the number itself. Like the same rule for cube root of a cube number is the number itself. Square root of a square number is the number itself. So the denominator is 2. And over here, x to the power of 8 times 1 over 4. So that's going to be 8 divided by 4, which is square. So x square over 2 is your answer. Question 23 says y is inversely proportional to x plus 1 whole square. When x equals to 1 and y equals to 5, find y when x equals to 9. So if it's inversely proportional, that means it's going to be 1 over x plus 1 whole square. If it was directly proportional, we wouldn't be dividing 1 by it. So it's going to be y equals to k over x plus 1 whole square. Replace the proportionality sign with the proportionality constant. So y equals to this. Now we put x equals to 1 and y equals to 5 to get the value of k. That's going to be 5 equals to k over 1 plus 1 whole square, which is going to be 2 square, and that's 4. 5 times 4, 20. So y equals to 20 over x plus 1 whole square. Replace x with 9. So 20 over 9 plus 1 whole square, which is 20 over 10 square. And that's 20 over 100 because 10 times 10 is 100. So that's going to be 0.2. That is your value of y. Question 24 says we have two functions, and in the first part, we have to find the value of f of 3. You will replace x with 3 in the function. So it's going to be 2 times 3 square plus 7 times 3 plus 4, 2 times 9 plus 21 plus 4, 18 plus 21 plus 4, which is going to equal 43. And it says find the inverse of g. So g of x is given as 2x plus 6. Start with replacing g of x with y. So now we have y equals to 2x plus 6. Right now, y is the subject of the equation. In order to find the inverse, we have to make x the subject. So we're going to begin with taking 6 to the left-hand side. So it becomes y minus 6 equals to 2x. Now we divide both sides by 2. So that's going to be y minus 6 over 2 equals to x. Last step is to replace x with g inverse of x and y with x. So x minus 6 over 2 is your inverse. Solve f of x minus g of x equals to 1. F of x was 2x squared plus 7x plus 4 minus g of x is 2x plus 6 equal to 1. So 2x squared plus 7x plus 4 minus 2x minus 6 equal to 1. Combine the like terms. 7x minus 2x is 5x plus 4 minus 6 is negative 2. Bring the 1 to the other side. So 2x squared plus 5x minus 2 minus 1 equal to 0, which is 2x squared plus 5x minus 3. Now we have to factorize this quadratic equation. So to factorize it, we first multiply the coefficient of x squared and the constant. So we do 2 times 3, which is 6. Next step is to find the factors of 6. So factors of 6 are 2 times 3 and 6 times 1. After that, what we do is we choose that set of factors which when added or subtracted gives us the middle term, which is 5x. Now we know 2 plus 3 is 5. But we also know 6 minus 1 is also 5. So what we're going to do is, I'm going to pick 6 minus 1. The reason why I'm going to pick 6 minus 1 is because if we had chosen 2 and 3, we wouldn't be able to fully factorize it. So I can show that over here. So if we had chosen 2x squared plus 3x plus 2x, replace 5x, this would be our equation. Then we would factor by grouping. So in the first two terms, we have x common, so x, so 2x plus 3. And the last two terms, we have 1 common, so it would be 2x minus 3. As you can see in the brackets, 2x plus 3 and 2x minus 3 aren't the same thing. They have different sides, which means we cannot further factorize it. The factorization stops at this step. Whereas over here, if we factorize the first two terms and the last two terms, first two terms have 2x in common, so x plus 3. And the last two terms have negative 1 common, so x plus 3. So that's going to be x plus 3 times 2x minus 1. As you can see, we can further fully factorize this equation because x plus 3 is the same in both the brackets. Whereas in the other case, it was 2x plus 3 and 2x minus 3. So we couldn't further factorize it. And so you have to make sure that you choose the right set of factors, because obviously you can have several options that give the same answer. But it's the sign of the chosen factors that also matters a lot, if it's giving this correct value and if it's going to help you further factorize the equation. So x is going to be 3 and x is going to be 1 over 2. That's your answer. Next question says 40 students can take part in 3 activities: art, dancing, and gardening. 5 do not take part in any of the activities. 12 do art only. 4 do dancing and gardening but not art. And 1 student does all 3 activities. So this is the 1 student that does all 3 activities. 5 do not take part in any of the activities. 12 do art only. And 4 do dancing and gardening, but not art. So that's going to come over here. On the Venn diagram, the ratio x to y to z is 1:2:3. Find the value of x, y, and z. So we know that this was 12, 1, 4, and 5. So total people are given as 40 over here. So what we can do is, if x is to y is to z is 1:2:3, we can say that y is 2x and z is 3x, basically, because they're all like getting multiplied with 2 and 3. So it's going to be 40 equals to 12 plus x plus 1 plus y plus 4 plus z and plus 5. So let's replace y with 2x and z with 3x. That is going to give us 12 plus 1, 13, 13 plus 4, 17, 17 plus 5 is 22. X plus 2x is 3x, 3x plus 3x is 6x. Then we do 40 minus 22, which is going to give us 18. So divide both sides by 6 and x is 3, which means your z is going to be 3 times 3, which is 9, and y is going to be 2 times 3, which is 6. So these are your values of x, y, and z. One subset in the Venn diagram in part A has no students. Use set notation to describe this subset. So as you can see, this has no students. So this is basically an intersection of art and gardening and intersection of complement of dancing. This part contains nothing from the dancing set, and this part comes between the common part that art and gardening share. So A intersection G intersection D complement. Then it says find the number of dancing, union, gardening, intersection with arts. Dancing, union, gardening is all of this. This is dancing, union, gardening. But if then it's just intersection with art, so that's going to be this region. So if we remove this region had 1 over here and x is 3. So it's going to be 1 plus 3 and 4. That is your dancing, union, gardening, intersection, arts. 3 and 1.